Hello everyone, welcome back. This is our Algebra 2 workshop on inverses. There are four objectives for this, and to do objective number one, I can describe and analyze the relationship between a function and its inverse. So, question number one, what is the relationship between the red function and the blue function illustrated on the graph? As you can see, these two functions are reflective about the y equals x line. Because of that, these two are inverses. So the answer to this is letter D. Number two, if f of x is equal to square root of 5x minus 10, find the range of its inverse. We need to graph this. Okay, so this is the graph of your original function, and now we're going to solve for its inverse algebraically. Change f of x into a y, and then now you're going to switch the y into an x and the x into a y. And then to find the inverse, you're going to now solve for y. Shortcut is to just put the negative 10 to the other side, making it become positive, joining the x on this side, and then now we're going to divide both sides by 5 to isolate the y. And now your new y or your inverse function is x plus 10 over 5 equals y. So now putting it in the function notation form, the inverse of x is f inverse x is x plus 10 all over 5, and then we're going to graph that. And so now the orange line is our inverse, okay? And they are reflexive about the y equals x line. And we are looking for the range. And because there is arrow at the bottom of the orange line and the top of the orange line, your range is the set of all real numbers, which is letter D. Let us now go to question number three. For which restrictions of the domain is the inverse of the function not a function? Let us begin. Okay, now, choice letter A. You're looking from negative infinity all the way to negative 1, which is kind of the same as from negative 1 all through the left side of negative 1. So let us go ahead and mark your graph. So your negative 1 is here, and you're saying that all of these from negative 1 all the way to the left side. And so that restriction will give it the inverse of this will give it a function. You already know, let us review that it is not a function if it does not if it does not pass the horizontal line test. And if you draw a horizontal line on this one right here, it will pass that test. So therefore, this is not the answer because this will create a function. Let us now go to letter B. You're looking at negative 1 all the way to the right. So from negative 1 to the right side, because this is positive infinity. So you're looking at this side right here. And this side right here again, once again, if I do the horizontal line test only for this side right here, it will pass the horizontal line test. Therefore, that's not what you're looking for. Let us now go to letter C. Letter C is asking you to look at from negative 2 all the way to 0, which is right about this interval right here. From negative 2 all the way to 0. Notice that what I marked is this V shape right here, this V shape right here, and this V shape right here will not pass the horizontal line test because if I draw a horizontal line right there, it is going to not create a function for the inverse of your graph. Therefore, the answer for this is letter C. Number four, the data in the table is for function f of x. Through which of the following points does the inverse of function of f of x inverse have to pass? So the x now becomes your y and the y becomes your x. So let's examine. There is none here that I'm seeing that flipped except for I see the 1 and I see the 1 right here. So now your x of 1 will not be here, it will be here. So I'm just seeing that the 1 became a 2, and so 1 also became a 2 on that one. So therefore, your answer here is letter B. Right, so let's take a look at number 5, which restriction would enable the function f of x equals 2x squared plus 4x plus 5 to have an inverse function. First off, graph it. Second, let's look at all your answer choices. It says that x is less than or equal to 1. 1 is right here, guys. right about there. That is your one. So therefore, if you're looking at less than this, you are covering all this left side. All this left side will not pass the horizontal line test. Therefore, letter A is not your restriction that will give your function an inverse because this will not pass the horizontal line test. So let's look at letter B. X is greater than or equal to negative 1. Negative 1 is right here. Greater than or equal to is going to be this right side here. This right will permit the inverse of this function. Therefore, the answer here is letter B. Now let's just take a look at all the other restrictions. It says that x is less than or equal to 0. So where is that? This is your x. And when you say less than, it's this left side. And again, this tiny part right here is not going to pass the horizontal line test. Therefore, that will not permit an inverse function. And letter D is greater than or equal to negative 2, and negative 2 is right about here. And when you say greater than, it's all this right side. Again, this tiny part right here will not allow the horizontal line test. Therefore, the answer is letter B. Number 6, the inverse of the function f of x equals 2x squared plus 4x plus 1. To have an inverse function must be restricted to the following, the range. So when you have a range, you're looking at the y values, which means that your eyes should be focusing on bottom to top. It says that it's from 0 to 6. So let's take a look at that. 0 to 6. This chunk of values right here will not pass the horizontal line test. Therefore, it's not A. Let's now look at letter B. Restrict the range to negative 1 to 4. Negative 1 is right here at the bottom, and 4 is right here. So again, this chunk of values will not allow the horizontal line test to pass its checking. So now restrict the domain. So now this is different because your eye should be looking left to right. Domain negative 1 to 0. This is negative 1 and this is 0. This part right here is what it's talking about. So therefore, this is the answer because this will allow the horizontal line test to have its inverse. But let's examine letter D, the domain of negative 2 to 0. Negative 2 is right about here, 0 is right about here, and this tiny values, set of values right here will not permit the horizontal line test. Therefore, your answer is letter C, which describes this chunk of values right here. Next example, what is the domain of the inverse function of f of x equals negative parentheses x minus 5 squared plus 2? With restriction of x greater than or equal to 5, we need to graph this. Okay, I'm going to show you how to put the restriction. So after you type your function, you're going to select this, and then it's the same. You're going to type up whatever it says there, and then you have to close your 5. You don't have to close it. It's going to show. So this is your function, and we're looking for its inverse. And right, so let us solve. Replace the f of x to a y. Now switch your x and y. Solve for y by isolating your y. So your first step is to put the positive 2 to the other side, making it become negative. Then copy down all this part right here. The next thing that you can remove is the negative 1 in front of this parentheses by dividing both sides by negative 1. This cancels out. And so this is now how it would look like. And your next step is to remove the squared by putting into the square root both sides. So now this side will just be y equal y minus 5. And then now you're on the very last step, which is to remove the negative 5 and move it to the other side. And if you move it to the other side, it turns to positive 5, which looks like this. And then now we're going to go ahead and graph that. Okay, so your graph looks like this. They are inverses, and the correct function notation for the inverse is this way. All right, so the graph on top is the blue one, this one, and that's your original graph. And this green one right here on top is your inverse. And then now the question is, what is the domain of your inverse function? So let's take a look and focus our attention on this one. The inverse has a domain which is left to right. So left to right, that is arrow, considered arrow. So that is negative infinity all the way up to 2. So your answer here is letter B. All right. Number 8 is more of the definition, and you should know the definition of your inverse. So let's take a look at this. If hx is equal to the inverse k1x, k negative 1x, which statement is true? This is a statement that's true because definitely that is your definition of inverse. And the definition is the composition of your first function with the second function and the composition of your second function with the first function should be equal to x. Okay, we're now on objective 2. This is your given function. Please graph it. This is your next function. Please graph it. And the question is, which of the following statements true about the relationship of f of x and g of x? We will find out when you graph them. All right, so that is your first function. And this is your second function. So therefore, we can say that those two are inverses, which is letter A. Please take note to put the restriction right here. And also, your negative 9 should be outside of the radical sign. Question number 2. Given the two functions, which of the following statements true about the relationship of f of x and g of x? Please graph them. All right, so this is your f of x function. Please make sure to put parentheses for x plus 5 so that they can be put as a numerator. And then here, you're going to plug in g of x. All right, so after plugging g of x, we realize that these two are not symmetrical along the y equals x line, which is here. Therefore, these two are not inverses. The answer is letter C. Next question. The two functions are defined such that this and this, which equation can be used to justify that they are inverses. So what's going to happen is you want it to equal to x. Therefore, here I can already eliminate those that says that they're equal to 1. So that's not going to be it. So when you do this, you've got to do the composition, which means that let's take a look. I'm looking at letter C right now because as you can see, the X here was replaced by all of these. So let's examine. Cube root is there, 3 is there, and then instead of X, you have the whole thing right there, which is that actually. And then after that, you have the plus and then the 15. The answer here, guys, is letter C. So objective number 3, I can graph and write the inverse of a function. Number 1 example, the function is restricted to the domain. Which graph represents the inverse of the function of f of x? Let's go ahead and graph this with the restriction. This is a graph of f of x, and then now we're going to put the restriction on the side using the inequality notation. On the inequality notation, this means that your x is less than 2, negative 2. All right, so after putting the restriction on the side, this is now your graph, and it has to be, the inverse should be the one that is reflecting this about the y equals x line, which I'm kind of thinking it's this way. Okay, that is your inverse, which I'm looking at B. Okay, question number 2, what's the inverse of this function? As you can see, I already graphed it, and your next step is to open up another window and graph all these with the right restrictions. So here I had plugged in choice A without the restriction first, and then I'm going to add the restriction on the side. Okay, see how wonderful these graphs are? They are symmetrical along the y equals x line, which means that letter A is the answer, and that is the inverse of this function. Question number 3, given the function f of x equals 4 minus 3x, if g of x is the inverse of f of x, what is g negative 8? We've got to graph this. All right, so this is now your function. I'm now solving for the inverse function of that one. Now switch to x and y, solve for y. So your first step is to move the positive 4 to the other side, changing the sign. Copy down the negative 3y and divide both sides by negative 3. So now this is your inverse function. And then now let's plug this to see the inverse function. The inverse function is now that black line, and we're now going to look for the y if x is negative 8 on here. So on the inverse function, if your x is negative 8, your y is 4. Just to note down, you can also look for that here because that negative 8 is really the y for this one. So if your y is negative 8, You can also locate it here. Your